In this third guided study problem on shear moment diagrams associated with beams, now we still have a simply supported beam that is, in this case, very short, only 1 foot long. We have very light loads, so this is a small little part in a machine. And so we have a reaction here at the left, a reaction out to the right that's been provided to us. Two concentrated forces of equal value but not symmetrically placed, and we have end moments that have been imposed. And in this third item we don't have near as much provided to us from the very beginning to work with. Right, so we're going to do our shear in units of pounds, and we'll keep in mind again that the slope of the shear diagram is given to us by the intensity of the distributed load. Wait a minute, there's no distributed load anywhere. So we're going to have zero slopes everywhere, but we do start off with a concentrated value of a force that immediately changes our shear from 0 to minus 20, follow the direction of the load, and then we have, again, no distributed load, so the slope is 0 until we get to the next thing that happens, and we have 30 pounds. Now notice here, the moment doesn't do anything to the shear diagram directly, and that's because what it did was it changed the reaction. It didn't change what the values were internally of the shear. Again, not directly. Right, so we have this minus 20 that then spikes and goes down to minus 50. Again, constant over, and because we're not necessarily so good at drawing truly straight lines, we want to mark both ends of those lines, make it very clear what we intend. We go down by another 30 to minus 80, and then we go all the way across, again, zero slope, and when you know it, we have an 80-pound reaction that takes us back and closes us off the way it should be, and there you have a good solid shear diagram. Right, now the moment here starts off with a smiley face 90 inch-pound, so that couple takes us from 0 and represents a positive discontinuity. Clockwise creates positive discontinuity in the moment diagram in the American system. Right, so we go bam up to plus 90, and remember dm dx equals v. So the slope of the moment diagram is given to us by the shear. The shear in this whole segment is a negative 20, so we're going to have a downwards sloping line. The change in moment will be given to us by this area, which is minus 20 times 3 inches, so a minus 60 to get us to a net of 30 pound-inches. Sudden break in shear, so sudden change in the slope, and the next piece then is going to be this 50 pound-inches per inch times 3 inches, so 50 times 3 will be 150, that of course will be negative, and so positive 30 minus 150 will take us to a minus 120. Again, integrate a constant, you get a straight line. And then finally we have minus 80 times 6, so that's minus 480 pound-inches here. And a minus 120 minus 480 will be minus 600. Get straight line variation because we have a constant slope given to us by a constant shear. And then we get, notice, remember we said clockwise moments we create a upwards positive discontinuity, and we were sitting here at minus 600. We've got the 600 then that kicks us up to 0. That's one way to look at it. The other way is to say we get to this far right end, we need to meet a frowning face or negative 600, and that's what we have.